everyone, welcome to the shop and welcome back to the Trent Pinion Mill build. Today we're going to make the knee support and what the drawings refer to as the knee support nut. This is the jacking nut for the knee that controls that axis of the machine. We're going to start with the knee support, which is turned from a piece of free machining mild steel. This is the piece that screws down to the base plate and carries the jacking screw nut or the knee support nut. A fair amount of material needs to be turned off from the outer diameter of this raw stock to form the mounting flange at the base of the part. You can see that they didn't leave a whole lot of extra for gripping in the chuck here. I started out pretty cautious, taking some rather light cuts, and then I started getting heavier and heavier just to see how things would handle. I figured we'd start this video right off with a big fat mistake, and in the spirit of not doing anything by half measures, I brought in the big guns, what for pointing and laughing.
Why is that funny to me?
If you're not going to do something yourself, then get the best to do it for you. Having mostly learned my lesson, I carried on with much lighter cuts. With the outside turned, it was time to think about drilling and boring. This part needs to be drilled through to clear the jacking screw, and it also needs to be bored for a recess for the jacking nut, the knee support nut as it's called, to run inside of. For the bore that accepts the knee support nut, I used a little boring bar that I ground from some 1/4-inch diameter high-speed steel. While the diameter itself isn't super critical, what is pretty critical is that it's a close running fit with whatever diameter I happen to turn on the base of the knee support nut that I haven't made yet. But in the spirit of trying to keep to the dimensions of the drawings, I aimed for the dimension that the bore was supposed to be, and I ended up being able to hit it within about 2 10,000ths. Pretty good, I thought. I reversed the work in the 3-jaw chuck, and I wasn't really concerned with radial runout, but axial runout. What I needed was to face the bottom side of the part so that it was perfectly parallel with the top side of the flange that I had previously machined. To do this, I indicated off of that machined surface of the flange. The flange was then faced to its final thickness. The 3 holes for mounting the knee support to the base plate are going to be drilled with both components clamped together so that everything is in perfect alignment. And the challenge here was with how to keep these 2 parts clamped against each other and still be able to machine the 3 holes. What I ended up doing was taking a bolt of appropriate size and turning down the head until it fit down inside of the bore that was put through the knee support earlier, and on the other side a washer and nut keep both sides fixed together. A huge shout out and thank you to my brother for making this really cool railroad track anvil for me. Now originally I was thinking that I'd drill these 3 holes from the bottom side, from the plate side. So that's how I had them laid out on the bottom side of the plate. It was around this time that I sort of chickened out and decided that I would drill them from the other side, from the knee support side. So I laid out the flange at the bottom of the knee support with the 3 hole locations and drilled from the top. Not to state the obvious, but the benefit of drilling all of the holes through both parts at the same time like this is that you don't have to worry so much about very accurate placement of the holes. Wherever they end up, they will line up between the 2 pieces. Because of that, I could easily get away with locating each hole using this carbide spotting drill, and then before moving on to the next hole, I quickly spotted the hole and then drilled it using the correct tap drill size. I did want to be a little pickier about how far each hole was away from the center of the part, so that they didn't look real inconsistent just looking around the flange. So I used a piece of paper as a shim between the body of the part and the carbide spotting drill. It just so happened that the diameter of the shank of the spotting drill was almost exactly the same as the width of the flange at the base of the part. Next is the brass knee support nut, and we'll start with that by turning the smaller diameter that runs inside of the knee support we just made inside that feature that I bored out. As I mentioned before, I'm shooting for a real close running fit inside of the other part. Next, I knurled the outer diameter of the nut, and for this application, straight knurls are appropriate, and I think they look pretty classy, so that's what I went with. Just a pretty simple bump knurling operation, but I use a cut-style knurling wheel in my holder, and that in conjunction with holding the wheel at a slight angle to the work really helps the quality of knurling on a small machine like this. The section you see being turned here is where the graduations will be placed. Now let's take our ADD back over to the base plate for a moment and turn our attention toward those knee support holes that we drilled earlier. We need to tap them for number 632 threads. The most convenient setup for marking the indexes around the nut would have been the Horth indexing attachment on my lathe. Since I don't have an indexing plate for it right now that gives me 50 divisions, this wasn't an option. What I decided to do instead was to use my shop-made dividing head. This is not one that I made, this is one that I purchased for a little bit of nothing and made some modifications to. I used it set up on the Little Machine Shop mini mill and just quickly printed out a table of cumulative index positions to avoid any compounding error. Each position was indexed to manually, and I used an 1/8" diameter high-speed steel blank that I just ground to a sharp tip, held in an R8 collet, and that was just dragged across the work to create the division lines. Every 10th line was 150 thousandths of an inch long, every 5th line was 100 thousandths of an inch long, and all the remaining lines in between were 50 thousandths of an inch long. For the remaining operations, the nut was flipped around and held in a 1/2" collet. Back over on the lathe, it was center drilled, and then tapped for M6 threads. And after that, it was transferred into a collet block and taken over to the mill for the last operation. The final operation on the nut, not including stamping the numbers around it, which I plan on doing later, is to drill several Tommy bar holes around it. To do this, I used a square collet block to index the 4 locations for the Tommy bar holes, and I started by spotting each of them with a small center drill, then drilling them to their final diameter. Then I went around once again with a larger center drill just to chamfer the edges. That's about all for this episode. I expect that next time we'll be starting to machine the column casting and probably making 1 or 2 sets of screws at the same time. As always, thanks for watching.